Alrighty, so here's the page where we stopped last time. And I honestly don't recall if that means that we talked about it or that we didn't talk about it. If I go take a peek at the code, I'll figure that out real fast. Let's see where we stopped last time. How far the notes went. All right, so we had the fraction class, we had SRAND, so we did talk about random numbers. Random numbers are cool because they make the assignments more interesting, right? It's kind of boring if I ask you to write something that'll let you enter, 10 test scores and calculate the average. I mean, yeah, I'm probably going to do that. But it's more fun if you write a program that'll generate 10 random numbers, right? Because then you don't have to type it in. Random number generation is actually a way that people tend to test parts of programs, right? Like you may fill up an array with random numbers so that you can test your sorting algorithms and stuff like that. So it wouldn't be a bad idea to go ahead and mention it again. But we can press on and then maybe hit the topic again. So you have to bring in C standard lib, and then you can call rand, which generates a random number between 0 and the largest int that the computer holds. It would yield the same sequence of numbers every time the program is run. Then srand initializes the random number generator with unsigned int x. Now that is one way of generating random numbers. I'm absolutely sure that there is also a random class that we can use. C++ random. Sure, there's a different way. Yeah, there's a header file called random. And what's nice about the random library is that you get the ability to generate numbers in very specific ways. You can say, okay, I want a number between 1 and 10 or something like that. That's worth playing with since it's different than what we did last time. So I'm going to make a new project. All right, I'm going to add some of my usuals, like the string and the CMath, and this time random. And I'm going to add using namespace std. There we go. Got all of our usual stuff here. Let's see how to use the random class. You know, the easiest way for me is just to Google up a C++ random class example. I was kind of hoping that I would do that right there, which we're already at. Introduces some random number generation facilities, gives us the ability to generate random numbers. You can pick which way you want your numbers to be distributed, uniform, normal, or binomial. It'd be interesting to learn what those are. And so distribution objects generate random numbers by means of their operator member, which generally takes a generator operator as an argument. So you could create a default random number generator. I've never actually done this, so I may want to skip it if it doesn't work. All right, so this is one way you can generate random numbers with a default random number generator. It has a couple of other methods built in as well, apparently. Alrighty, and then we can use our random number generator to give us a random number. Now, I don't understand what this is doing that has to do with the next. Couldn't I just do this next line without that first line? Let's see if that is actually the case. All right, so the uniform int distribution. We're going to be making ints. And apparently we're going to be making numbers between 1 and 6. Let's take a look again. This really isn't as easy as what I was thinking it would be. An int dice roll is equal to distribution generator. Oh, okay. So you do need all of them, all of the above. And so lastly, we can make our random number here, our dice roll based on the generator, which is a default random engine, and it's going to give us a uniform int distribution. We could look up the difference between the various forms, but uniform sounds pretty good. Like, you know, you're rolling your dice and it's not going to tend to, tend too much towards any one particular number. Sounds good to me, right? Let's write a loop that'll print out, 10 random numbers between 1 and 10, just for funsies. If it's going to be between 1 and 10, we better put a 10 there. So for int I is equal to 0, semicolon, I is less than or equal to 10, semicolon, I plus plus, that's our standard for loop, which I know we haven't hit the chapter on, but we know what a for loop is. We've taken other programming languages and it's pretty obvious. Alrighty, and so let's get our die roll. Could just take this and cut it and paste it and put it here. And let's print it out. Let's see out I so that we see what roll it was. And then say roll is equal to, end quote, a couple more less thans, and print our dice roll, followed by an ENDL. So we should see it print our 10 numbers. Let's make them 20-sided dice. We're Dungeons and Dragons players now. We're going to roll 20-sided dice. Here we go. Give it a shot. Let it run. And there we go. There's our random numbers. I don't know if that's any easier than the other way or not, because the other way I would just have to # include that thing and then use the rand function and modulus it to the range that I need. It seems pretty easy to me. But it is another alternate way, right? So let's add a comment as to what we're doing. Generate 10 random numbers, each number in the range 1 to 20, using the random library. All right, so that's what we're doing. All righty. So we have several possibilities. Moving on. Hand tracing a program. This is an extraordinarily tedious topic to lecture about, but too bad, we got to do it. Usually I get on a whiteboard and do it, and I'm not going to be able to get on a whiteboard, am I? So let's figure out another way to do it. Maybe I can do it with Excel. I'll put Excel on one half of the screen. Really? Add table data from pictures. Neat. All righty. Okay, so fill up half the screen with an Excel spreadsheet. And the other half is going to have some kind of program in it. Let's open up good old Notepad. And we're going to just write some silly little program. Now, I'm not going to actually write it in Visual Studio because this is just for sample purposes. Okay, so we're going to write a program. It says int x is equal to 0. I don't care about the semicolons because I'm not going to run it. Int y is equal to 1. And then we're going to have while x is less than y, right? X equals x plus y, y equals y times 2. If y modulus 3, or how about y is plus 2? Yeah, so we're going to start. Yeah, this is going to be over real short. Now that I'm thinking ahead. Okay, so anyways, and if y modulus 4 is equal to 0, meaning if it's evenly divisible by 4, then y equals 2 again. And then we're going to see out x and y. That's what our program is. That's kind of what it's supposed to do. So we're going to hand trace it. Here's our variables. We're going to have an x variable and a y variable. And maybe if we print anything out, I'm going to put it here, right? Sorry, call that output. And maybe if we were going to type in anything, we might have another column for that, but we're not going to. Okay, so right now we're executing that line. X becomes 0. Now we're going to execute that line. We're going to pretend we're a computer. So y becomes 2. Whoopsie. So now, while x is less than y, is x less than y? It sure is, because 0 is less than 2. So we enter the while loop. X becomes x plus 1. I could have just written that as x plus plus, right? So now x is 1. And I'm not going to bother copying that, because I could copy these each time, but I'm only going to write down when they change. All right, and then the next line, y plus equals 2, right? Y plus equals 2. So y becomes 4. And then we check again. While x is less than y. Wait, we didn't do the last thing. If y modulus 4 is 0, then y is equal to 2. I kind of see a problem with my logic here. This is kind of dumb, but we'll keep going with it. Okay, so y got changed to 2 here because y modulus 4, it is 4, so it's evenly divisible by 4. And so this line changes it to 2. And then we print out x and y, right? So in our output, we're going to print out a 1 and a 2. All right. Then we go back to the top of the loop. Is x less than y? Yeah, because x is still 1 here and y is 2. So definitely, still x is still less than y. So we come back in here. What happens next? Oh, we're going to add 1 to y. Excuse me, add 1 to x. X gets bounced from 1 to 2, gets incremented. Y plus equals 2. So it becomes 4 again. Whoops, that was supposed to be on the next line. So we go here, becomes 4. If y modulus 4 is equal to 0, yeah, that's true. So y becomes reset to 2. We come out here to the next line and we print out x and y. All righty. Then it loops again while x is less than y. Yep. 2 is less than 2? No, that's not true. So it exits the loop. I could have made it, at less than or equal to give myself one more run through it. But after that, yeah, let's do that. Just do it one more time. Okay, so that is true because I changed it to x less than or equal to. So y gets incremented 1. It changes from 2 to 3. Excuse me, x gets incremented 1. Y goes up by 2. So it becomes from 2 to 4. We can see that it's always 2 after this loop is done because the very next thing it does is check to see if it's modulusable by 4. It is. And so it drops back down to 2. And then we print out x and y. And then we come back up here. And if x is 3 and y is 2, we exit the loop and we're done. So now we have hand traced the program. Now, the times that I've done that have been very far and few between because the debugger lets me do that, right? I can just do that in the debugger. I'm not going to even save that, right? I can set a breakpoint. You set a breakpoint by clicking, you know, the red thing over here, and then you run in the Windows debugger, and it runs the program and stops at this point, right? And we can check to see what our variables are by bringing this page up. And right now we have a variable I that's been created, but it doesn't have any data in it yet. So I'm going to skip step over if I can find my toolbar, right? And now we've entered the for loop, and I is set to 0 because that's what we told it to set for. But it hasn't run this line yet, so we don't have a die roll. So I'm going to skip over again, right? And now I can see that it got a die roll of 13. And so I is 0, and the die roll is 13, and the next line is going to print that out, and so on. I've shown you this before. But it's just like hand tracing, right? Except the computer's taking care of everything. So I'd rather do it that way. But if you have some code, a printout of some source code, and you don't have access to the computer itself, or the only thing you have access to is Excel, you know, piece of paper with a pen and paper, whatever. Okay, so I'm going to quit at that and then remove the breakpoint. But now we have covered hand tracing. Why don't I stick this in the notes? And if we're going to print something out, let's make it look a little bit better with at least a space between them. All right, so now we're going to run it again. I should have saved that Excel spreadsheet so we could check our comparison to what we actually get, right? It printed out 1, 20, 1, 2, 2, 2, 3, 2, and then stopped, which is, as I recall, actually what the Excel spreadsheet predicted. It's just not putting any end of lines in there, which is making the output look ugly. So there we go. Right. 1, 1, 2, excuse me, 1, 2, 2, 2, 3, 2. That was our expected output, and it stopped because X was no longer less than Y. I'm not going to walk through their example since we already did. A case study. General Crates Incorporated builds custom designed wooden crates. You've been asked to write a program that calculates volume, cost, customer price, and profit. And so they give us some information. Variables, a whole bunch of variables. Now they give us a code for this, I believe, if we look down, but it'd be more interesting for us to write the program ourselves, right? So cost per cubic foot, charge per cubic foot, length, width, height, volume, cost, charge, and profit. Well, let's try to get those going. Now I'm just going to enter it into Notepad and then copy and paste it because Visual Studio takes up so much space. Cost per cubic underscore foot. That's one of our variables. These are all going to be doubles, right? So I can just copy and paste that word double every time. And what is it? They want that to be set to 0.23. All right, and then they want one called charge per cubic foot. Hopefully that's more than the cost or we won't be making any profit. Looks like it is. And then so we have some more standing for length, width, and height. And then we have one for volume. We have one for cost, charge, and profit. All right, let's go copy and paste these. Cut, copy, whatever, and put these into here. So let's see out what we're doing. CGI crate cost calculator. So those are our programs. Since they have these in all caps, they're implying that those are constants. So I'm going to go ahead and make them consts. The rest of them I could initialize to 0. I'm going to see what happens if I don't initialize them to 0, because I'm probably going to be asking for the values and letting them be typed in and stuff like that. And so that was a override the values anyways. But you know, if it makes you feel good, there's nothing wrong with initializing everything to 0. It's just usually not necessary, because you're usually, the first thing you're going to do is ask for that value, right? Or then you're going to calculate that value. But there's nothing wrong with doing that. All right. It's just kind of superfluous. Some programming editors will kind of complain even if you do that. You initialized it with an unused value. I don't think C++ does that. Could be wrong. If I build it, or would you? All right. So I'm going to check the error list, see if it is in fact giving me any warnings about those initialized values. It's not letting me drag this very successfully. Oh, now it is. And I've dragged it off the side of the screen. Tell you what I'm going to do. All right. I think we're good to go now. View the error list. Any errors? Nope. Any warnings? Nah. Okay, so it doesn't care that we've initialized some values that we're ignoring. What's next? Let's go find out our logic. Program design. The program will ask for a crate's volume, the cost of building the crate, the customer's charge, and the profit made. So we have to ask for the dimensions of the crate. Let's just go ahead and write that in. We know that's going to happen. Cout lesson, enter lesson, and then CIN greater than. And I'm just doing that so that I can copy and paste these, because I'm going to know that we're going to ask them to enter the width and then enter the length and then the height, right? And then so we will let them type in the width variable, the length variable, and then the height variable. And so we can calculate the volume pretty easily. Volume is equal to width times length times height. And now we can figure out the cost, because the cost is going to be the volume times cost per cubic foot. And we can figure out the charge, because the charge is going to be the volume times charge per cubic foot. So cost equals volume times cost per cubic foot. Charge is equal to volume times charge per cubic foot. And then we can calculate the profit, which is the charge minus the cost. And then we could output this stuff, right? Customer charged, less than, charge, less than ENDL, Cout, material cost, less than cost, less than ENDL, and then Cout, profit earned. Of course, that's not including the cost of labor, right? But whatever. And then so we put the profit here, and then our program should be done. So enter the width, sure thing, 50. Enter the length, 40. Enter the height, 30. And there we go. Customer charge, 30,000. Material cost is that, and the profit earned is that. Ooh, we made a lot of money by building a 50-foot crate. And that makes sense. It's pretty hard to build a 50-foot crate. Now, what would be interesting is to change this into an object-oriented program. And so what I'm going to do that is I'm going to come up here and I'm going to create a class called crate. And every crate has a height and a width and a length, right? And every crate, no, we're not going to put a variable for volume. Instead, we're going to have a function that calculates volume. And we need a function that lets them type this stuff in. You know what? We could actually go to the trouble of typing in the whole word, right? So let's define a function, and it doesn't need to return anything, in my opinion. So void input underscore data. And it's just going to do the exact same stuff that this one did, right? So I'm going to just copy these and paste them into this function right here. All right. And now we need some functions for calculating the volume. So let's write a function to do that. Double calculate volume. I could just call it get volume, right? That's a and to calculate volume, we return this arrow height times this arrow width times this arrow length. And I like using this reference, so I actually wished I'd put it in front of all these as well. So I'm going to go ahead and do that. The advantage of typing this arrow is it gives you a list of all of your variables in your functions, right? So you're far less likely to get any typos if you use this reference. Quite often it's not strictly necessary, but I like the syntax, right? Please enter the width of this object, right? Please enter this object's length. Please enter this object's height. All right, so we've got get volume. And now we can do get charge and get cost, right? Well, to get the charge and the cost, we're also going to have these two variables. We definitely need the charge per foot. Still don't know why we're making them constant. What if we need to change them? But we're going to still keep kind of following their rules. All right, so there we go. Let's write the get charge function. Which returns this arrow greater than get volume times this arrow greater than charge per cubic foot and let's do get cost as well. Double get cost, where we will return this arrow greater than get volume times this arrow greater than cost per cubic foot. And I forgot my parentheses. This is a function call, right? We are calling that method, so we do need the parentheses. And lastly, get profit, which is the charge minus the cost. So double get profit. And then we need an output, a display, right? To display all the information that we had down here, right? When we were displaying the cost and the profit and the material. Did I do a get profit? Yeah, get profit is totally wrong. I don't know what I was doing there, right? Because the profit is this get charge. Come on, let me delete everything. Right, this arrow greater get charge, parentheses in parentheses, minus this get cost, right? All right, now we're good. And so now we can write a function. Let's just call it void. I mean, it's not going to return anything. Display. And so we can say the customer was charged by that. I left off the this keyword this time. Not any particular reason. And that. And get profit. And we might even want to say what the dimensions of the crate are, right? Like when you buy something, you like to see a receipt that said what you actually bought, right? So crate dimensions cout height equals less than height, cout space width equals less width, and then cout length equals less than length, followed by an ENDL. I guess we could put like a comma after each dimension. So height is equal to something, comma, width is equal to something, comma, right? I think that makes sense. All right, let's run it. All right, so the width of it's going to be 2. Oh, I never actually called the code, right? So I'm not actually testing it. I'm testing the old version, not our object-oriented version. Okay, so what I'm going to do is I think I'll just comment this part of it out. So I'm going to put, oh, I could probably comment it out using the edit menu, right? Highlight all of that, all the way down to the bottom here. Good enough. And then choose edit, advanced, comment out, toggle line comment or toggle block comment. All right, now it's all commented out. And now we're going to replace it with the object-oriented version. So we have crate C1 dot Okay, now it's not letting me actually type in what I want to be able to do is to do c1.getInput or whatever it's called, and then c1.display. However, those are not public members of the class, so I can't access them from down in main. I need to scroll up here, and I'm going to say, okay, why not just make them all public? So I'm going to put public : right here. Now let's try it again. There were build errors. All right, show me the output from the build, please. Where's my error list? Is it going to tell me over here? Nope, nope, don't want to do that. All right, so view the error list. Okay, I just typed it in wrong, right? It's not called get input. What is it really? Input data. All right, so I go and replace that. Input data, right? There we go. And since it's object oriented, we could make it so that we typed in 3 crates, right? We could create crate 1, comma, crate 2, comma, crate 3. And then we could input C1, C2, and C3. And then we could display C1, C2, and C3. So that's kind of the advantage of object-oriented programming. By moving it into a class, we were able to, use it over and over and it would have been really messy to copy and paste all of that code, right? These 20, 30 lines of code over and over and over, when we can just copy a couple of lines to reuse that functionality. All right, maybe I got it to work now. Let's give it a shot. Alrighty, so the width of the first one is 1, the length of the first one is 2, and the height of the first one is 3. Now we're in the second one. I guess it ought to say something a little bit more interesting than merely width, so that we can differentiate. But anyways, this one is 2 by 4 by 6, and this is 6 by 8 by 10. And then it's going to display all 3 crates, right? I guess it should have displayed the volume. Well, we can add that, right? Wouldn't take too long to add that. And the get input ought to be a little bit more interesting. Let's display, scroll up here, C out, less than, maybe a line of arrows. And then C out, I don't know why they called it CGI, Crate Builder Inc. Well, if it's called that, I'm going to call it CBI, right? And then one more row of dashes just to make it look pretty. I forgot my semicolon here at the end. Okay, and then we could display all that message, right? Get all that stuff. And so on the display, we can make it look a bit prettier. See out, crate purchase. Maybe we want to put a nice little row of things like that, right? And maybe one of those at the bottom as well. And let's also print the volume. So C out, less end quote, crate volume, colon, space, end quote, less than, get volume, less end quote, cubic feet, end quote, backslash n, backslash n, end quote, semicolon. And since we said this is in feet, I guess we should have been doing that all along, right? Oh, well. Maybe we could just say cubic dimensions in feet there. And maybe we should tell them up here, CIT less than, please enter all dimensions in feet, \n, end quote. All right, now it's all fancy. Let's go ahead and run it. All righty, so please enter all dimensions in feet. Enter, see, we could ask how many crates, right? Wouldn't that be fancy? Anyways, this is going to be a 1 by 2 by 3. This next one's going to be a 2 by 4 by 6. And the next one is going to be an 8 by 10 by 12. And here we go, right? Our crate purchase, it's a 3 by 1 by 2. 6, I guess these are being displayed in a different order than what I typed in, right? Because I have width, length, and height. So it's in a slightly wrong order, but I could fix that pretty easily. So this last one down here. Why don't I copy this stuff? 2. Steal those 2 lines and put them right here. Being very particular, this is how I would try to actually make it look if I was going to give it to a customer and they wanted a console application like this. Alrighty. And so we're going to put height third. Yeah. All right. Just do one more time. And there we go. Pretty. Alrighty, so we solved their problem and we did it 2 different ways. I'm hoping that if we keep reintroducing the ideas of the object-oriented programming before the chapter where it gets introduced, they bring it in too late, in my opinion. And that's why I'm bringing it in early. So we wrote a class, and the class allows us to contain the information of the height and the width and the length. And it allowed us to break up the data input and then the calculations and then the output like that. So we were able to use that stuff in a really nice way. We just create 3 crates. We ask the data to be input for all 3 of them, and then we display all 3 of them. Okay, hope that makes sense. I'm going to skip the rest of theirs. They do give a solution. It'll look a lot like the first way we did it. And that's the end. They don't even have a summary. That's all right. We know what we got out of it. We are done with chapter 3, however. So we need to go and look. I need to make sure that the quiz for chapter 3 is published. Let's go and take a look. Oh, it needs to be imported. Okay. Well, I won't waste your time me doing that during class, but I'll do it immediately after. All right. So we're going to have any homework over that? Let me think about that. All right. So the homework, Below is shown code that calculates interest. Modify it to ask for the values of A, rate, years, and N. So there's an interest formula, compound interest formula. I should just modify it to actually show that, right? Compound interest formula. Let's just paste that picture into the it's there, but you can't see it. It's because it's black. I need to disable the. All right. We'll just put that right into the homework assignment. Make it a little bit clearer. Right. All right, so homework, the formula for calculating compound interest is shown here, right? Below is shown code that calculates interest. Modify it to ask for the values of A, rate, years, and N, which are R, right? And then years is T. We'll modify it to say that as well, right? So once those values have been input and converted to floats, let's change that to double. It should calculate P, the money after interest is accumulated, and print the results. So modify the code below to allow the user to input A, rate, years, and N. Feel free to choose better variable names for A and N. And then use good prompts, not input A, but messages like, what is the starting amount? What is the interest rate? For how many years? How many times per year? All right, see, I gave you too much code. This makes the assignment too easy. But I'm not going to delete it. All right, so turn in the CPP and a screenshot of the output. All right, so that's one of the homework assignments. I think we have another one that's appropriate as well. So let's go look at that. And the other homework assignment, since that other one's pretty short, write a program that, okay, I should give an explanation up here of what we're doing. If you take chemistry or physics courses, you will run into the ideal gas law, which allows you to calculate volume, pressure, mass, or temperature based on, that's about enough of that, right? And so we're going to write a program that has us ask for all this information and calculate the pressure. You aren't expected to actually understand this, just follow the formula given. All right, so task, write a program that declares variables P, V, N, R, and T. Make all variables double, declare them one per line. Why don't we go get a picture of that law too? Ideal gas law. PV is equal to nRT. That looks like a good picture to grab. Let's grab this one. It's kind of far off the screen there. There we go. Grab that picture. I should turn the recorder back off for this part. All right, so that is the ideal gas law. It shows the equation, but the variant we're going to be using is to solve for P. So it's going to be nRT divided by V. And like I said, the assignment actually gives the equation. So let's go take a look at it. So your task is to use the ideal gas law to allow the user to blah, blah, blah. So write a program that declares variables P, V, N, R, and T. Make all variables double, declare them one per line, and add a comment to each line saying what the variable represents. And in part 2, allow the user to input values for V, N, and T. Assign R 0.021 because it's a constant. Make the questions meaningful, like what is the volume of the gas in liters? What is the temperature in Kelvin? Part 3, calculate the pressure with this formula. So you're just going to use this formula right here. Part 4, display the results. The output should look something like this. Pressure is 75.3 atmosphere. If that was the result of the calculation, which it is not. If I correctly recall, P will equal about 1. If you use the values 22.4 for V, 273.15 for T, and 1 for N. So that's your test data. Okay. All right, hope that makes sense. Submit your source code and a screenshot of the folder running. All right, I think we're going to end the lecture a little bit early this time. We've got 2 homework assignments. I think that we've done a good job of covering 3. I will publish the quiz, so that'll be another task that we have to do. And do you have any questions? You doing okay? All righty. So I will see you Monday. Talk to you Monday anyways.